Thanks, Jackie, and thanks everyone for joining us today. My name is Srinivas, and I have been working with Jenkins, Spinnaker, and continuous integration for more than 2.5 decades now. And most of this presentation is going to be walking us through how Jenkins has evolved and where we are today. Really quick on OpsMX. We have a mission to deliver software without human intervention. So we are a company that promotes and supports Spinnaker. In addition, we also have products based on machine intelligence, machine learning that adds to the continuous delivery process. You can see we have interesting set of customers here. Uh-oh. Okay, so before we get started, it'd be really good if you can have a quick poll to
Okay.
understand what our audience is. Over to you, Jackie.
Okay, I'm launching the poll. So the first question is, are you currently doing continuous delivery? If yes, with what percentage of your production applications? And the second question is your organization currently evaluating or using Spinnaker? So I'll give folks a few minutes to answer that. Come on, friends, don't be shy. I know there's plenty of attendees. Okay, we've got 50% have voted. Can we get up to 80? All right, so you've got 20 more seconds before I close the poll. Five more seconds. Okay, so I'm closing that poll. Okay, do you want the answers now, Srini?
That would be really great.
Okay, so here are the results. So for the first question, 7% said yes, they dev and test only. And then 43% have said yes, less than 10%. And then 36% said yes, more than 50%. So those are your top percentages there.
Wonderful.
And then for the second question, so they are evaluating Spinnaker, that's 50%, and 36% is said not evaluating or using Spinnaker. So I'll stop sharing those results. Okay, the floors are yours.
Thanks, Jackie. So quickly going over Jenkins. Jenkins came up sometime in 2004, 2005. It was originally designed to be a build server, or rather an integration build is what we used to call in those days. It was a big relief because we have multiple development teams. They're all developing stuff. And then we try to compile all of that together. It wouldn't even compile because somebody has changed something in the headers and whatnot. So Jenkins became, in time, the de facto standard for continuous integration, where it's built capabilities to take the source code, compile it, and then over time it has capabilities for creating Docker images out of that, and so on and so forth. And even today, Jenkins is probably one of the best build servers available, open source, free, and it actually doesn't need any support. Very simple, fairly simple to use, and allows for automated triggers from Git and so on and so forth. So this is typically how a Jenkins pipeline would look like. We have developers who check in code into a repository, uh, maybe GitHub, or one of the similar source code repositories. Jenkins can be set to trigger from Git and build the source code into executables, deployables, whatever you want to call it, the build artifact, so to speak. And this stuff is put onto a machine or in a cluster, and then it's executed. And against that, we are able to, either use it or run tests, and then also check how it's doing. This is really how Jenkins typically is being used today. So coming to deployment, and what is deployment? Let's understand how it used to be done in the 90s. When I said deploy, what I used to do is basically copy over the executables to the server machine, usually with using root access, and then either simply kill the old process, trigger the new one, bounce the web server. Web servers came later, towards end of 1990s. Or simply copy over the jar and trigger something so that the new class files are loaded. That's deployment. As time progressed, now we have load balancers, we have cloud. So how do we deploy on a cloud infrastructure? Typically, we'll have a command line interface where we do the same thing, except that using the cloud's command line interface, which essentially is just the executable calls the cloud's API and push it to production. This essentially does the same thing. Copy over the files, restart the server, configure any additional configurations that need to be done, and so on and so forth. As these things became more complicated, what we started doing was we started writing scripts, typically shell scripts before Jenkins days, where you do the same thing, except that instead of we having to issue one or two commands, the shell script or Perl script would simply do the same thing. And we used to call that automation. A lot of it you can see even today, where you start with one or two line script, put it into Jenkins or our job, and then gradually this script starts growing from 2 3 lines to 10 lines, 20 lines, and then at some point it becomes unwieldy. What we are talking about deployment today is an application is already running, our customers are already using 24/7, the application is up, and now we are deploying a newer version of the application. And we want to make sure that the application remains available before, during, and after our update. This is what we are talking about deployment today in this context. We want to be sure that the deployment has gone through nicely and the customers are continuing to use our newer updated version of the application. And worst case, something goes wrong. Ideally, it should automatically roll back to the previous version, or worst case, with one click with a human intervention. Our, of course, vision is that there won't be any human intervention. But however, there is even if a human intervention is required, it should not be a big deal. It should be just a single click rollback. This is the kind of model we are looking at. If I remember correctly, in uh, 1990s, late 90s, when internet started coming up and we used to have online banking. And yesterday I went to actually Wells Fargo Bank, and there they had this in 1997. I remember personally, I had an online bank, It was so cool to be able to access bank from home. Today, the expectation is that the online bank is going to be available 24/7. It's not meant to go down and be just available from during daytime or nighttime or whatever. And this is the model we have come to use to, whether it is online banking or is it you know online streaming, videos, online movies, chat. Everything is supposed to be on 24/7, and that's become a social expectation at this point. Spinnaker, that came from Netflix. Spinnaker was outsourced by Netflix in 2015, I believe. Maybe I'm a bit wrong there, 2016. And it's designed with this in purpose. Spinnaker is an application designed ground up for deployment. And one of the things was that came up later on because of the cloud is also the infrastructure control. So Jenkins builds, and there are tools that talk to cloud infrastructure. Spinnaker, on the other hand, is designed to talk to the infrastructure. So the cloud APIs are built in. So most of the popular cloud, whether it's AWS, Azure, and GCP, Google Cloud, all the APIs for these clouds are built into Spinnaker, which allows Spinnaker to be able to interact and talk to the infrastructure itself. Couple this with a very, very well thought out pipeline concept. So Spinnaker has built pipelines or delivery pipelines that allow you to define different stages, dependencies, and fairly complex level of conditional control that allows you to execute pipelines in a well thought out manner. With infrastructure control, it becomes possible to create pipelines that ensure that complex, relatively complex deployment strategies such as BlueGreen or Highlander, Canary deployments, automatic rollbacks become possible. This is because the pipeline is integrated both with the delivery and with the deployment and also with the infrastructure. So, for example, blue-green deployment would require some sort of control over the load balancer or somehow the network routing to the old and the new version. And all these are designed ground up. This is not an afterthought. This is not a plugin. This is not something that Spinnaker was designed to deploy and then somebody decided to add these features. No, this was designed ground up for this purpose. So if we now take a quick comparison between Jenkins and Spinnaker, it's obviously not a fair comparison. Jenkins has its purpose, its place in the ecosystem, and so does Spinnaker. However, we can just take a quick look. In Spinnaker, deployment artifacts are first-class objects. So one could say that, what does that supposed to mean? Let's say I have deployed um, an application in a test server and we have tested it, we are happy with it, now we want to deploy it in production. And we can, of course, go deploy it in production. However, how can we enforce, confirm that what is deployed in production is exactly the same thing that was deployed in the test environment? With Spinnaker, you can do that. It's very simple. Once the artifact, let's say a Helm repo, has been baked, it is in Spinnaker, it's inside Spinnaker's database. Even if somebody goes changes the Helm repo, exactly the same thing will be deployed to production. It will not be a new version. And this is the power of a Spinnaker in the pipelines, which not only makes sure that we are able to execute pipelines logically, but we are also able to enforce the logical thought process that goes into pipelines as part of the system, as part of the tooling, as against a script or expectation from team members, for example. So this is one core difference. Another core value addition is it's already multi-cloud. Multi-cloud, it was designed to deal with cloud infrastructure. It also handles on-prem deployments. It comes with the ability to handle security and secrets. It has inbuilt integration to a lot of uh, tools and applications that are used in the CI/CD ecosystem.
Srini, we have three questions. I don't know if you want to address them now or do you want to address them at the end of the webcast? Let me know.
Let's do it right away.
Okay, so Bernard has a question. He says, what is a Highlander deployment?
Yeah. Okay. So Highlander deployment is typically what is like what you would call as normal deployment, which is you bring up the new application, and as soon as a new application is up, you simply delete the previous instance of the application. That's Highlander.
Thank you. And then we have, is Spinnaker available as SaaS?
Yes, Opsimex is providing Spinnaker as SaaS. That's also capable of deploying to on-prem uh, Kubernetes clusters.
And then our last question right now is, even with Spinnaker, you still need a CI tool like Jenkins. What is the purpose of this comparison then?
Absolutely. So this is a question that we're going to answer as we go further down, that these two tools complement each other. They don't compete with each other. And each one has a purpose. Yes, you can use a screwdriver as a hammer. Very frequently, I have done that, just turn the screwdriver around and use the stub of the screwdriver as a hammer. It's just that it was never designed for that purpose. So that's really the answer to the question, and more on that as we go forward, Jackie.
Thank you.
All right, so let me quickly go to this one. I've just completed that. And then there is also this concept of risk assessment. We have a custom, we have a environment, we have an application that's already running there. Customers are using it, and if you have been in, uh, you know, in teams where we deploy an updated version, there's always this tension, this fear that the new version will somehow screw it up, and we are going to be sitting in meetings with managers. And there is a risk, and that risk comes from a various set of unknowns related to the application's performance in the production environment. Typically, functionality testing would have been done well before that. Everybody is happy with the functionality. It is just that in the production environment, there is always this unknown as to could something different happen. Spinnaker has mechanisms to make sure that using metrics and logs, it is possible to evaluate the newer version before routing 100% of the customer traffic to the newer version of the application. Coupled with the blue, green, or canary kind of deployments, it becomes possible to ensure that the the impact is minimized or the risk is minimized, and we don't go into production with an application that, for example, consumes 20% more CPU or 50% more memory, which causes some issue that was not visualized before. There's also this whole concept of approval mechanisms, where something might go into production without appropriate approvals or verification. And Spinnaker supports that with very, very easy integration to make sure that we have verification and approvals in place, not as emails, not as PowerPoints, not as tickets, but approvals built into the pipeline execution itself. That is, without the approval, it will simply not go forward. And this is what is already built into Spinnaker. I'm sure it's possible to do it in Jenkins or any other tool, but that would involve some scripting. Visibility is another feature of Spinnaker, where what it does is that all the pipeline data is stored in the database. So you have data that says how much time a pipeline has taken, how much time a stage has taken, uh, whether a pipeline has failed or not. And by analyzing this data, we can, for example, find out which pipelines are failing most frequently, which pipelines are taking longest, how much time has been spent waiting for a human judgment, manual judgment as we call it. So historical data and trend analysis becomes possible. And then by analyzing this data, we also know what are the most commonly occurring errors. And by root causing them and fixing them, hopefully we make the entire CI/CD pipeline smooth as silk. So this is really the answer to the question. Now, what is a comparison? It's not a comparison. Jenkins is a fantastic tool for build and continuous integration. This is what we use at OpsMX. In OpsMX, we use Jenkins for our builds. It automatically triggers based on the Git check-in. There's an automated build process. It triggers automated tests, uh, and so on and so forth. Spinnaker, on the other hand, is suitable for automated deployment. And by using Jenkins and Spinnaker together, we are creating a lot more reliable integration and deployment pipeline, which will allow us to do it more frequently. We are not talking of improving the reliability by 10%, 20%. We are talking of improving reliability by 10-fold, 100-fold. If we are going to be deploying multiple times in a day, the entire process better be very, very reliable. If we are deploying once a month, in a year, maybe we are deploying 10 times. If we are deploying once a day, we are deploying 300 times. And if we are deploying 10 times a day, we are deploying 3,600 times per year. And that requires a much, much higher level of reliability in terms of our build, in terms of deployment. And that's what Spinnaker is all about. So this is roughly where the whole thing fits in. We have developers checking into GitHub, which triggers Jenkins. Typically these days, microservices architecture and containerized applications will create Docker images. Spinnaker takes the YAMLs or whatever the artifacts are, plugs in the latest updated image, and deploys it to either AWS, Kubernetes, Docker, Azure, OpenStack, OpenShift, and so on. Pivotal is also supported. So this is roughly a representation of how a pipeline today looks like. That we already have something working, we have a newer version, and then we deploy the newer version into a compare and take a decision whether we want to go ahead with the new one or not. If it's successful, then we go with the new one. So this is roughly what Spinnaker, where Spinnaker fits into the entire ecosystem. So let me quickly take you through a demo of some of the sample pipelines we have created. As you can see, these pipelines are available to everyone. You can go and take a look and actually use them. These are excellent samples that makes creating new pipelines very easy by looking at what we already have. So let me quickly go through these pipelines one by one. The point that which was made is that Jenkins comes pre-integrated. Sorry, Spinnaker comes pre-integrated with Jenkins. So there is a Jenkins stage in Spinnaker, and you can see that you can select which Jenkins instance, which Jenkins job you want, and we can trigger the job and then also get the properties of that job, any values, parameters you want. You can get them back into Jenkins, and you can actually see them and use them. So here, for example, there is an image ID, and this is the image ID it has got from Jenkins. So particularly when you are doing the builds over and over, typically the image IDs might be automatically created and tagged either with the git hash or with the build job number or something like that. And we'll be able to get that in Spinnaker and use it as a variable. And so the same uh, deployment descriptor, for example, could be deploying an updated image on each build. So this is a Jenkins stage. So at this point, I'd invite all of you to ask any questions. And Jackie, please do interrupt me if there are more questions here as I run through these pipelines.
Okay, sounds good. We don't have anything in the Q&A right now. Oh, actually, just kidding. What is recommended? A, integrate Spinnaker pipeline with Docker Hub, or B, with Jenkins?
Well, that really depends on the how you want to trigger your pipeline. What is the basis for triggering the pipeline? At OpsMX, we integrate with Jenkins. Yes, as you can see, you can have pipelines trigger from Git or Docker or Jenkins. It's your choice. We prefer integrating with Jenkins because that's where the image gets built and the image gets pushed to Docker. So in case you have other mechanisms for pushing the Docker images, for example, maybe you have different Jenkins jobs and different Jenkins instances from where a particular Docker image could be getting pushed into the Docker Hub. So that would be an example scenario where you would trigger off of Docker repo as against from Jenkins.
Okay, I've got a couple more.
Mhm.
Docker is going away from the Kubernetes stack. By the end of this year, what changes should we bring or prepare for?
Yeah, Docker is going away. Containers are not. Containers are here to stay. So it is just a different format. So I don't think Docker is going away anywhere anytime soon. Docker as a company is different from container. So different organizations are moving to different types of containers. And eventually, my guess would be that the container itself will become an open standard. That is where the big companies are pushing it right now.
Okay, one more. How does Spinnaker compare to Argo CD?
Sure. Argo CD is uh, if I don't know much about Argo CD, so I probably should not give an answer to this one. But Argo CD is Kubernetes specific, if I remember correctly, whereas Spinnaker is works across clouds and has much higher level of integration with a whole bunch of CI/CD tools in the ecosystem.
Okay, thank you.
This is
So
my guess.
we won't hold you to it. We've got a couple more. Once Jenkins pushes the image to Docker Hub, it is appropriate to integrate Spinnaker pipeline with Docker Hub instead of Jenkins. Is that correct?
As I said, it really depends on the source of the trigger. At what point do we want a Jenkins pipeline to deploy something using that image? Now, if that trigger is Jenkins, so be it. If let's say apart from Jenkins, we have a team that could manually update and push the Docker image, and we want to deploy based on that. That would be an example where you would have the trigger from Docker Hub.
Okay, a few more just came in as well. What are your thoughts on Jenkins X versus Spinnaker?
Very frankly, I don't know. So I will not comment on that. But from last I heard, Jenkins X was losing steam, but I could be totally wrong.
Okay, so can we include the pipeline definition in the same Git repo as the application, or do we have to create it from the Spinnaker interface?
That's a very good question. There is no need to use Spinnaker for creating pipelines. You can actually create it outside. You can create it manually using any other tool. A pipeline in Spinnaker is nothing but a JSON file. And it is possible to store pipeline in Git. And I'll show you shortly that we can even synchronize pipelines in Spinnaker with a Git repo, or the other way around, is to get all pipelines from a Git repo to Spinnaker. So this is something I'll show later in the demo.
Okay, one more question. There are so many SaaS CI/CD pipelines now: Circle CI, CodeFresh, Garden, Azure DevOps, AWS has many components. GCP is coming up with its own package. My head is spinning. The method we talked today is gearing towards self-built pipeline.
Pipelines will always be different. Every application, every company, every environment will have something different. So we do have a lot of templates. We do have a lot of examples which could be lifted straight away in most cases. But then every company has to have its own pipelines, however subtly different they might be. I don't think we have reached a point where we are going to have a one size fits all. Uh, and technology is evolving, newer technologies are coming up. There will always be easier, simpler ways of doing things. And to say that there is one solution that fits everybody today, or it's going to happen in future or foreseeable future, I think it would be a bit too much. I'm not sure if I have answered the question, unfortunately.
Okay, no problem. I don't have any more questions in the Q&A, so we can move forward if you want.
Sure, thank you. So we just saw a Jenkins stage. Now this is an example of a Jenkins trigger. So in a Jenkins trigger, what happens is that we configure which Jenkins we want, and we select a controller and a job. And then whenever that job runs, maybe that job runs because of a Git trigger or a cron or someone manually triggers it, Spinnaker pipeline will automatically trigger. It will go ahead and evaluate the variables it has got. Again, we have used the example of an image ID, and then we'll go ahead and deploy a manifest using that particular image ID. So this is an example where a Spinnaker deployment pipeline could trigger right after a Jenkins build process without any human intervention. Now we move to a simple Kubernetes deployment. Very simple. Manifest is here. You put it, select the account. You can choose a different namespace if you want. You can select different accounts and different namespaces over here and deploy it. And then, of course, we can also delete the manifest. We're just going from simple to complex, so please bear with me. Same concept, Kubernetes deployment, except that we do not store the manifest here, but the manifest is in a Git repo. So if you go to a Git repo, we can see here kube deploys, simple deploy. So this is the manifest. Now here we are only referring to the URL of that manifest, which is stored in Git, and deploying it wherever we want. Same concept. You can select which account you want, where you want to deploy it, and then which namespace you want, and so on and so forth. Absolutely same thing, except that your deployment manifests are also stored in Git, can also be version control, can also go through approval process, PRs, and so on and so forth. Same concept we can do in Amazon. We have, let's say, an AMI. We can just find that AMI from tags and then deploy it. Absolutely same concept. Our AMIs are created elsewhere. Maybe we have a standard set of images in AWS and we want to deploy them. And after deploying it, we want to do something. I'm showing very, very simple pipelines that do only one thing. Uh, and obviously, all these pipelines can be concatenated. Pipeline is also a stage, so you can actually call one pipeline from another pipeline. So let's take a look at Kayenta canary analysis. Now here what we are doing is that we are doing a build, and then we do deploy a baseline, which is an existing version of the application. And then we deploy the newer version of the application. And then we run a canary analysis. Canary analysis is uh, a stage which will take metrics from these two guys and make an assessment as to how these two are different purely based on statistical analysis of the metrics. And then it goes ahead and checks whether the conditions match, whether uh, the newer version is okay, and then it goes to a manual judgment where you can also see whether you're okay with it, and then it goes ahead and deploys to production. So this is a simple example where we are using Kayenta for canary analysis. But instead of Kayenta, we can also use the OptimX's proprietary autopilot, which does the same thing, except that it also analyzes the logs from the application and does a bit more.
Hey, Srini, you've got a couple questions in the Q&A. So can the manifest source be Terraform?
Yes and no. We have a custom Terraform stage, and we can take the Terraform script from Git and execute it as part of a custom Terraform stage. So yes, it can be, except that it is not coming by default in Spinnaker. It's fairly easy to set it up. I think we have documentation on our website that lets you see how it can be done.
Thank you. And then the second question is, when you are using the deployment YAML from a Git repo, how can you replace the referred image with the latest container image tag?
Yeah. So let me just, it's a very interesting question. It needs a bit of an explanation. Please bear with me. Um, and I'm just looking for a correct example I can show you, but while we wait for my application to respond, Spinnaker has built-in variable replacement thingy called Spring Expression Evaluation Language. Most of Spinnaker is built on Java Spring, and it'll locate variables. So here, this is what I was looking for. Skip spell expression evaluation. So when you have a deployment descriptor YAML in Git, you would put it as an expression. So you won't hard code it as this one. This is an image Nginx 1.14.2. Instead, what you do is that you are going to put it um, as a variable, like it's been shown here. So this you can see is an expression which is saying, from the trigger properties, get me the image ID. So when this is being deployed, uh, Spinnaker will automatically replace this expression with a value. And uh, that value, the evaluated value, will be put here before deployment. So because of that, the power of Spinnaker in terms of expression evaluation and substitution, it becomes possible that every time Jenkins or a new version of the image comes, it's automatically put into the YAML. Any more questions, Jackie?
Nope, that's it for right now.
All right. So Kayanta Canary analysis is what we have seen. Let's quickly move to the next one, which is a BlueGreen deployment based on configuring the ingress. Now, when we are, I show you, I don't want people to panic. It's pretty simple, um, but the underlying concept is that we have an application that's already running. An updated version of the application is going to be deployed. What we want to do is split the incoming network traffic, typically from our customers, or it could also be from a test application, and make sure that a small percentage of that traffic is routed to the new version while keeping the majority of the traffic to the old version. And as we are analyzing it, we scale down the old version and scale up the new version and gradually shift the traffic from the old version to the new version. So instead of a big bang, you know, entire network traffic going to the old version of the application is suddenly switched to the new version, you're doing it slowly, percentage by percentage. So you can decide how much percentage of the traffic you want and shift it to the new version. And again, as I said, this is a very simple example where we are doing it once, but typically you may have multiple stages of this where we are going with 5%, 10%, 20%, 50%, 75%, and then 100% is switched to the other one, and then simply delete, the the old version. So as we are doing this, you also want to scale the infrastructure. So as the network traffic is routed from the old version to the new version, you are scaling down the nodes or the infrastructure of the old version and scaling up the infrastructure for the new version so that the customers don't see any degradation in performance. So this is an example of that, where we are routing uh, the traffic by managing the ingress controller for network splitting. There's a similar version for using Istio, but I don't have that one here. Then we have other examples for deployment. It's very easy to do a Helm deploy. This is one of the examples I gave you. A Helm deploy requires a bake stage followed by a deploy stage. And once we have baked it, it's fixed. And we can make sure that the same baked version is deployed in production or in a different environment, irrespective of what has happened to the original Helm repo. So it kind of gives us a level of guarantee that what is tested is what is deployed. At the end of the day, when you think about it, it's a fairly simple common sense statement saying, hey, we should design and develop what is designed, and we should test what has been developed, and we should deploy what has been tested. Sounds so simple. When we have hundreds of developers working on multiple applications in a complex environment, untested code going to production is not news. It's happened many times. Many of us have experienced it firsthand. And a lot of these processes are really designed to make sure that the controls are in place in the tooling, in the system, in the process to prevent that from happening, even if a human tries to get around it. And a lot of that is built into Spinnaker using role-based access control, which we are not going into in this particular session.
Hey Srini, we've got a question in the
Mhm.
Q&A. So following up to the last question, if using Spinnaker spell expression language to set the image tag, GitHub can't be the single source of truth, or can Spinnaker push this back to GitHub?
That depends on the information we are talking about. Expression is an evaluation, and that data is available. So if you, it's definitely available in the logs, and if this data is what we want to save and be able to see later on, and say what, tell me what version of image was deployed in production, then it can certainly be found out. So it's the auditability is definitely a feature in the OpsMX enterprise for Spinnaker. It is not there by default in Spinnaker, but the information that you are looking for is very much available in the Spinnaker database.
Okay, that's all. Thank you.
All right. If we are using customize, it's possible to deploy customized charts also. And you can see it's very similar to Helm chart. So the beauty of Spinnaker is the familiarity of the UI. As we switch different providers, switch different Kubernetes accounts, it's the same look and feel, and the same concepts apply. Whatever you are deployed in one environment, you can simply deploy to another environment by simply switching the account name and potentially the namespace. We also have runtime policy integration. So policy might be that we don't deploy to production on new moons that fall on Mondays. So if we have complex policies, be it related to timing, or we don't deploy applications that have a load balancer requesting an external IP address, for example, these policies can be enforced in the pipeline. Typically, these policies are reviewed, people are informed and checked, and so on. But here we can actually enforce it. So, unless the policy is evaluated and it passes, it will not go forward. So, in the policies, we have two policies. One is called a runtime policy, and it's called a static policy. Runtime policy is basically evaluating the variables at runtime, time being one of them. At what time is the pipeline getting executed, who is executing it, and so on and so forth. What we also have is called as a static policy. um, I think let me just give a minute here. So static policy is when you design the pipeline. So when you design the pipeline, it could be saying that, you know, when um, an image cannot be deployed to production without having passed a security scan, let's say. So even when the pipeline is designed, the system will not allow the person to save, saying, hey, you need to have a scan stage before production, otherwise you cannot have that pipeline simply cannot be created. So that's called a static policy, and Spinnaker supports both runtime and static policies. So that's end of the demo. uh, Jackie, any more questions before I move to the next set?
I do. I have two questions. So, in a couple of previous slides, it was mentioned that it supports fetch and store secrets and security in secrets. Can you describe the list of technologies that it supports and what it's supported? I.e., for example, HashiCorp Vault. Does that make sense?
Absolutely. So Spinnaker does support secrets and encryption that is natively built by Spring. Natively is supported by Spring. I cannot go into that at this point. However, integration with Vault is fairly easy because Vault supports integration of secrets in Kubernetes environment, and using very simple techniques, it is possible to have secrets available to our uh, YAMLs and other artifacts in Spinnaker pipelines. All this without having the secrets show up in the UI. So yes, it is possible.
Okay, thank you. And then the following question is it possible to deploy multiple applications with a single pipeline? Each application will have its own build and deploy in lower environments, but needs to deploy as a bundle in production.
Absolutely, it's possible, and we can even do it separately or together. So depending on how we design the pipeline, there are what are called conditional expressions in Spinnaker. So we can use those conditions to ensure that everything is either happening together, or everything is happening one after another, or in a particular sequence, and so on and so forth. So yes, it's absolutely possible using conditional expressions.
Sorry, that was it for right now.
All right, thanks, Jackie. This is just a quick look at OpsMX Enterprise for Spinnaker. As I mentioned, Spinnaker supports just about everything. What OpsMX Enterprise for Spinnaker does is adds a bit of functionality and usability on top of information that's already there in Spinnaker. And then we also have a machine learning based autopilot that does analysis of logs and metrics of applications to make sure that your application is operating within the parameters against a baseline. And this kind of helps with automated decisions, automated rollbacks, continuous governance, and so on and so forth. Visibility and insights. As I said, a lot of this visibility and insights is actually data that's already there in Spinnaker. That's possible to visualize it a lot more easily using a UI. So this is what AwesomeX Enterprise for Spinnaker is all about. As I mentioned, Spinnaker comes built in with a lot of integrations. On top of it, AwesomeX has added more integrations, and you can see this eye chart, which has just about anything and everything people might be using. Really quick um, case study. One of them is Cisco, where we have more than 400,000 changes deployed every year, and more than 1,000 applications, and we have more than 12,000 developers. So one of the points of Spinnaker is that it's built to scale. It is designed as a microservices architecture. So Spinnaker itself is composed of 7 or 8 microservices, and they are scalable. So they are horizontally scalable. If people know what that means. So as the load increases, we can simply increase the number of instances of, Orca, Cloud so on and so forth, and we can very easily scale. So it is um, designed for scale and designed for speed. And we have another example here of a leading American secure messaging. This is a chat actually, which is used in banks and other things. As a secure chat. It needs to be integrated with the backend and stuff like that. And they're using Spinnaker. We are able to reduce the customer onboarding time from days to 15 minutes. So whenever they have a new customer, the new customer can be up and running in 15 minutes. And it does use, as somebody asked, Terraform. It does use Terraform integration in Spinnaker, and it automatically provisions the AWS infrastructure and sets up the whole thing all in 15 minutes for the customers to use. So these are the kind of velocity and scale we are talking about in 2021.
I've got a question before we jump into the last poll question. Do you support custom plugins? For example, if you have an API layer in front of Vault, can a custom plugin be written to pull secrets from this API?
Yes, it is possible.
Okay, let me relaunch. Okay, so we're relaunching the poll. And if you can take some time to answer number 3, which is please follow up with me regarding Spinnaker training, onboarding, support, schedule a demo of OpsMX Enterprise for Spinnaker, schedule a complimentary CD strategy workshop, or I would like to be sent the presentation materials. So we'll give it a minute. We've got 30 seconds to submit your Okay, so I'm going to end this poll. We'll quickly share the results. So looks like we've got some folks interested in Spinnaker training, onboarding, or support, scheduling a complimentary CD workshop, and then also they'd like the presentation materials. So I'll stop sharing this now. Okay, Srini, all yours.
All right, I'm open for any more questions at this point, and the contact information is on your screens.
Okay, so we've got about 3 minutes till the top of the hour. Folks want to enter your questions. I'll help moderate through the Q&A. Oh, thank you. Okay, Srini, looks like no more questions. Oh, here we go. Does Spinnaker play well with Prometheus for monitoring?
Absolutely. So Prometheus metrics, monitoring metrics are built into Spinnaker, and Kayanta actually uses Prometheus metrics. So Prometheus and ELK stack go very well with Spinnaker.
Okay. Any more questions? We've got a minute left before the top of the hour. Okay. Srini, thank you so much, and also OpsMX for joining us today to talk about Spinnaker and Jenkins. It was such an informational session, and it was also really fun to have a lot of interaction from the attendees. So thank you.
Thanks, Jackie, and thanks everyone for joining us today.
Great. This concludes our webcast episode. Okay, bye.